Okay, moving on to question 6 of thermodynamics tutorial. So we are given this reaction, okay, and we are given the delta S for this process. Now, if you take a closer look at the equations given to you, you are given enthalpy change of formation. And now the question was very specific. I want to find the delta H of this process as well as the delta G of this process. Okay, so that we can use the delta G to explain why copper hydroxide is sparingly soluble in water. Okay, so in this case, these are all your delta HF. Since we want to find the delta H of this reaction, we can make use of this formula, delta H formation of products minus reactant. Okay, so in this case, substitute in your delta HF of your products, which is copper 2 plus 64.8 and hydroxide negative 230. You multiply respective by coefficient. This is similar to what we have discussed in thermochem 1. Alright, sub in the values, solve for your delta H. You get positive 54.6 kg per mole. To find the delta G, we're going to make use of this delta H value as well as the delta S value to find delta G using the formula. Okay, so delta H should sub in this value here. Sorry, we can sub in the delta H value over here, right? Positive 54.6. Delta G is what you want to find. So since delta G is in kJ per mole, reminder to convert your delta S into kJ per mole per Kelvin. So this negative 196.2 J per Kelvin per mole. Alright, you can see me dividing by 1000 here in order to convert into kJ per mole per Kelvin. Alright, sub in the values. Temperature in this case will be at 298 Kelvin because of the 25 degrees Celsius. So we concluded that delta G is more than 0. Okay, and therefore this process will be not spontaneous. Okay, that's it for question 6.